Right. Okay, then I would give it a start, sure. Or do you want to
Go ahead.
start with longer? Yeah, great. So I put this topic in, which is called "Is there room for an industrial IoT work group?" I would like to use a few slides as introduction, just to kick off the discussion, and then have more time on discussing on it. Let me see. Yeah, I took a look on what we're doing in ELISA, and as the title says, enable Linux. In safety applications, we have a strong focus on Linux. And our working group so far, as you most likely know, is software architecture, the Linux features for safety application. We have the OSAP work group, tool investigation, and then inputs generated, as we could see in the welcome slide, for automotive use cases, medical device use cases. But mainly I see that we use a Linux system running most likely on a microprocessor. I keep it wide because we have no explicit hardware typically in mind. Sometimes we use a QEMU or so, and this was just there. But we are mainly focusing on Linux kernel related libraries, tooling around it. When I take a look, as I'm coming from automotive, I see there is much more. So I will shortly go through architectural elements. I see containers popping up here and there. And typically, when you have an automotive use case, there is another real-time OS in there. So it's next to the microcontroller on a microcontroller. Sometimes it's also an application OS-less or so, natively compiled. But this is needed to have very fast response, like being able to respond in 50 milliseconds after boot or so. And there often a Linux system is not fully capable of handling all the responses from code boot. Then in the next step, I see that there were requests in adding other operating system next to Linux, which could be that they say, well, we would like to have another separated security cell. We would like to see another OS for rear seat entertainment, for example, could be an Android OS or so. And suddenly virtualization comes into picture. So we see that it's growing with microcontroller, microprocessor virtualization, RTOS, and then typically applications running on top of it. And we figure out then, well, we would like to control maybe our air conditioner cell. So we go into the RTOS, who has the control about the device and the fan around it. So we have some inter-core process communication. And yeah, these days, of course, the car gets connected. So we have over-the-air update, we have app stores to load new apps, get some service business around it. And this all need to fit into very good tooling. Could be Yocto-based, and all of this will need to be a proper SBOM generation. There's a lot of CI/CD tooling around this, and we see there's a lot of things growing outside of this system. And now it's all automotive. You may say, what is it now? We're talking about the industrial work group. For this, you see a similar architecture in the product lines. So it's not only for automotive. Also, if you think about the industrial area for robotics, for medical devices, there's often a separated core part, really with an RTOS, but then there are control interfaces, PC-like things, and therefore it has to fit for multiple product lines also because the lot sizes are different there. In consumer electronic, there every 6 months there are updates, and you have no time to create your product again and again. You would like to reuse and scale. So this is something, just in summary, which is observed. And yeah, if we look back at this, what we do in automotive, we have very limited resources currently, and that's why we concentrated on our use case and writing also onboarding documentation and put this into practice. So really concentrating on a Linux core system, even going to QEMU simulation to reduce the hardware complexities, and we simplified wherever reasonable. And at some point of time, we may reach a point where our simplified architecture hits reality. And the reality was looking like this. So people would like to see, sorry for this, how do things look like? So we have an HMI, which could be demoed, and to illustrate certain things, we tried this with the AGL cluster demos. And we will have a small migration from the different things. So we have the HMI user interfaces, graphic user interface, depending on which use case you are, they're called differently. We have maybe still some real-time OS in there. If we talk about lower safety integrity levels, where then higher safety integrity levels is covered by an RTOS, but still there's room for Linux in there. And yeah, our system and our discussions which we take need to see that our complete system which we operate gives so much room for interference, so much more to think about than just a very simple Linux-centered cell. And yeah, so therefore I sought for joining these forces to form a stronger umbrella work group, so that automotive alone does not need to handle all these use cases, but that all like medical, industrial, other parts, building technologies can form such a work group where we can also set up a demo system and place then our concepts or blueprints, whatever we do, kernel configurations, toolings in there to see that it really works in a real live architecture. And then things like RTOS, which we by intention left out in our last 3 years, or container. We had this question in the welcome session, we also left out. And so therefore we bring in concepts, but we can also prepare on the very long run. And for now, this is what I say, I put it in, I want to see it booting. This is what I recently heard from another discussion where yeah, the thing where there were continuous talks on conference, and again there was every year a new feature added, new functionality, new ideas, but the people already struggling in see it booting. And in discussion with AGL, for example, we also saw that there are setups, but the interesting part is, for example, to get an RTOS with a CAN message, which communicates properly with an AGL Linux OS, maybe virtualized as a cell, as a VM in there, and to meet this use case, to really showcase this is something how a close to reality system looks like, and that's where we fit in. I made up my mind on a few discussion points. So the issues which I see, which make it a little bit harder, is from the other part, there are demo systems. It's quite an effort. So there are many communities which try to maintain it, but it's always also hard to keep them up on date. And we are not such a strong, large project. So it's really important to interact with other projects like AGLX and Community Zephyr and so on, and have the umbrella maybe in ELISA. And my second strong concern on this is that someone who may claim that the things are already safe, because we provide something which is source code, and someone say, well, this is ELISA, they have a demo, so they prove there is a safe Linux in there and this demo is safe, but that's not the intention of it, right? So, and therefore you can see that many topics which we have in there, like updating, how do the SBOM look like and so on, we have to face them. They will be part of a mixed criticality system, but they have not the direct related safety like the other work groups have. And well, we would gain the benefit of having a showcase vehicle, and we can better tie together the results of different work groups. But this is the benefit of it, but it's really a discussion point. So that's why I brought it here. I could see reasons for doing such an industrial work group with maybe more soup-based safety standard approach. So we say we look more on a smaller safety standard, like Jason was pointing out with the UL 1998, or concentrate also on the environment around it. Right, this is where I want to stop and say we could get into discussion. So
I like the edits on the slide. Good one. Actually, medical devices working group has the same sort of story that automotive. Linux doesn't exist on its own, and using the STPA analysis let us finally drill down into Linux and the Linux portions. But the real world out there is all systems, and we really don't have any way of sort of tackling the partitioning and constraints associated with systems. The STPA analysis, I think, has been giving us a good way of structuring it, but talking about those issues that will impact this system and overall safety, I think, is something we should be starting to talk about as a group, and be it called industrial, be it called, system,
Yeah,
or something like that. It seems like this is a conversation we should be starting to have, especially as we combine. Linux doesn't exist on its own in isolation. It has to be part of a system.
exactly. And this is also where we do the SDPA analysis in automotive. We also saw, I guess Chris was very strong in also promoting. He said, yeah, we did our QM demo, we set something up, but we need to put this into practice. We can make up our mind, we can do all this analysis, but we really need to see how does it match to the use case, how does an implementation look like, and we will figure out much more issues and much more things to discuss than just taking the paperwork. And therefore, we shouldn't do too over complicated and making more complex than needed. But ignoring this complexity will most likely also not help in the end.
Yeah, sometimes it's not even the complexity; it's just the messy parts that come from working with real systems. Yeah, we've done some work with a demo system based on a Raspberry Pi, for example, which is obviously not a great hardware basis for a safety system, but it is something concrete, and you can start to work through some of the challenges with it, some of the limitations with it, and understand where using particular hardware gives actually you've got actually additional responsibilities for the operating system. If you've got hardware that's got some safety guarantees, but that relies on the operating system running some checks on the hardware periodically, that's another thing that you need to make sure that you're factoring into your safe operating system. So I agree. Going for a relatively simple use case that we can explore some of these concrete things in would be good. And if doing that in an industrial or IoT context is a way to make that happen, then yes, that sounds like a good plan.
I also just named this basically IoT or industrial because I also saw automotive in the end is nothing more than a large combination of IoT devices. Okay, what you said, like system is also a good approach for it because in the end it's about the real system which you later on build and not only some subsystem which we call maybe system from our perspective for now.
Yeah, I think the other aspect that I'm sort of interested in exploring is in making the system level information available for safety in a concrete way too, because we're starting to see the need for more transparency happening. And I think Bob will be talking about that in the keynote a little bit later, but having a system that we have as reference that we can sort of illustrate best practices will help evolve some standards as well.
Yeah.
Mm-hmm. Heard from Paul. Shiva, what's your thoughts here on this one? Since you're sitting in medical with me.
Right. So definitely one thing I noticed is having a smaller scope, like for example, OpenAPS, and being a well-defined way to evaluate the medical use case has helped us. It narrowed the number of things we need to look at. We are also now be able to even install OpenAPS on in a virtual environment, even without the hardware, and be able to get a feel for a footprint without specific devices, hardware devices, and be able to evaluate various error cases and so on. So I think limited scope, I'm with you that limited scope, and now being able to narrow the scope and be able to do analysis on that, the smaller footprint of the operating system that we're looking at is going to be very helpful for us.
Yeah. One of the things we really, updates and applying fixes, bugs happen in software, and we really don't have any place to explore the what happens when you go and update the software. What analysis should you be doing? what, how do you draw the boundaries to keep it reasonable for analysis? I think these are topics that kind of make sense to start exploring because Linux gets a lot of patch updates.
Even on an LTS branch.
Exactly. I think it's about
Right.
one update an hour actually on the LTS branch as opposed to 9 on mainline from the last set of stats I saw. So I think that's sort of there. I guess the challenge is going to be. Go ahead, Paul.
And there's other open source components that you'll be wanting to take patches from as well. So
right.
Figuring out how and when you consume those patches and how you then verify your safety arguments still there. Yeah, I think that's an absolutely essential thing to do. And given that we've got the server that the tools working group set up and maintain, we could have a kind of building systems and consuming patches there to illustrate what the process looks like and what the challenges are. I think that would be a useful thing to do.
So my thoughts on that is that it is not very different from other spaces do this, right? Other products and existing products, not specific to it. This is not a problem that's specific to just the safety critical systems. It is same for it. It in some ways, how do we manage the incoming inflow of the patches is the same across the board that products that use Linux. The added complexity for us is being able to have a baseline safety analysis and then a delta of that, meaning when we see patches, can we identify the areas that have changed? Like, for example, if you are seeing 10 patches coming in and you say, this impacts memory management, for example, say. So that you have to figure out a fine tune. How do you continue have a baseline analysis and how do you continue to do safety analysis on the new content that's coming in? That's probably the challenge, coming up with the process to do so.
Yeah, that's something that I spent a lot of time looking at, which boils down to what do I actually need the system to do, and how does that affect safety, and then defining requirements for that and tests for that, and being able to actually run those tests on your updates from the upstream projects, so that you can say, has this broken my assumptions? If I've assumed that this open source product behaves in a particular way, and that's the basis of my requirements on it, then I need to make sure that it continues to behave that way, or that I know when it stops working that way, that my assumptions are no longer valid.
Right. Paul, you're also right that that's where the tools working group, what we already have there, we can use that infrastructure and we can use the servers there that we can continue to evolve and refine the process of figuring out how to go about doing a continuous safety analysis, so to speak, as the new patches, new content comes in, and how often. The other thing is how often, once you decide, okay, this is the stable release, how often we have to give guidelines on how often they want to do that. That's up to the individual products to decide. But stable releases come out once a week, right? How often is the question too.
Well, I'm sort of wondering, can we figure out, is there a good candidate that we should start to look at as a system that we want to start doing the analysis on, that we know that will need to be updated and that everything is open source? I think one of our requirements is we need an application that's going to be an application in a system that all the components are mostly open.
And that's, that kind of brings us back to the sort of the industrial IoT. Do we open up our opportunities by sort of having a working group focusing on this? And I guess the other key thing is, does it bring in more people to ELISA to work on this by expanding the scope.
Yeah. So I could imagine we bring in a few people for it. It's a little bit, but as Shua said, there are so a lot of projects, initiatives around already face the same issue, right? They are in a similar situation. What I had on the previous slide is that we also get better insight with other communities, first of all, because I see that it makes sense that on the diagram I showed there was a Xen Yocto project, Sapphire in, so that we're also discussing more actively with other projects assisting, because maybe also from how we had the 2 years back a talk from the Xen project, which showed that their foods are way, but we haven't get in touch with them anymore. And by their thought, if we bring these things together from different communities, we also get more insights, we get more exchange, so that we are not in the ELISA world, but also just forming the umbrella of it, and then just see also if we find partners. Of course, the use case is also strongly combined. So I put this also in the picture here. I've also mentioned CIP, Civil Infrastructure Platform Project, which also has a similar use case scenario. Maybe they also don't look at the artist, but I think if I saw their slides properly, they have also virtualization in scope and containers on the long run, not challenging it yet. We're still being on the way to add it, but they also form this kind of architecture. So the question is ELISA the right place? Is there a better project? Someone will say, well, there it goes. Or is it a good chance for us to also interact and attract some partners? So maybe those which are still new and look into such a scenario.
So I can see sort of 2 opportunities there. One is to look for safety-related applications that maybe aren't currently running on Linux, or running on some kind of an RTOS, but that would like to sort of port their application to Linux and sort of understand the limitations on that. That might be one possible partnership to form. Another one is to actually consider a system which where the kind of system as a whole features an RTOS as well as Linux, where you're relying on the RTOS for some parts of your safety argument and Linux providing others, and they're kind of working with Zephyr on that, for example, might be interesting. But again, it comes down to a system use case for a particular domain, and I think that's where I think some kind of new input, some new participants, probably bringing in ideas for particular systems would be really interesting.
Yeah, I think the systems is what we really want to tackle, and if we can get a use case going, fine. Possibly starting it off with the automotive one since we've got that, but starting to look at system aspects more might be a way to sort of move it forward. But I'm just curious if anyone else on the call has ideas about industrial types of use cases or industrial systems that might be amenable to be looked at from this context, or some pointers.
So I know that on a low level of, as it's not on these complex parts, but I know that consumer goods like smart home equipment is an interesting business which could be approached. I recently read in the news that Hire, who is doing home, so like oven and other smart things, they want to have a smart product, and their product liability comes fast into action. If you have an oven which you would like to control, you need to make sure that that the kid is, or the cat is currently not in the oven for some reason or whatever, or is not entering the mixer or so, and that you have a lot of control things in there. and this is another level of safety, of course, but this is appliances, and this thing is that there are existing products which are suddenly confronted due to getting smarter, getting connected. They get safety elements to be considered which haven't been there in the past, but they can share use cases on this, and yeah, and maybe this is also more open, more, I don't know how open they are, but I know it's competitive. The vacuum cleaner, for example, or the mower robot outside, they also need to take care that they don't kill a mule or a hedgehog. Also that your vacuum cleaner robot is not interfering with a cat or any other, with a hamster or so. There's something which all need to be taken. So you also improve everything there, and then you want to remote control your devices. You would like to see where they have been, so you have a lot of connection in there. There's risk for intrusion, what could happen from a security pass to interact, and they have a strong demand also on considering more general concept, because it's not that they are selling they may sell 1 million dishwashers or whatever, but they are selling this over different models. They have they have a product line, but each chunk may just be on 1,000 units, and then the next unit comes. If you look on your vacuum cleaner, just for the back end there, you can see how many support are there for how many different. This spec is used for so many different brands and devices. So this is something where we could get maybe some audience and attraction, which is more than from the IoT driven, which suddenly get confronted with safety.
No, those are good ideas in terms of applications. I guess it's going to be a question of seeing if we can find some open source prototypes or systems of them that we can probably pull in.
Yeah.
And to see if we can find a community that's interested in working with us.
Yeah, and at least from some research work which I did on the net, I saw that there are combinations of where they come from an RTOS and where they suddenly need to put in new features which are no longer fit into an RTOS. And they get at it then either with a Linux or an Android or whatever, and they need to be fast to market. They need to innovate there. They have a highly competitive market, and they then they need to argue a lot or struggling a lot with base functionality. So
right.
they will sell their product if it's not safe and secure. So maybe, and they just bring it into the market, and they have lost later on, but they still will go fast to market, but they're not selling it as a feature. The feature is usability, software updates, value add, which they gain later on, because the functionality itself is still given. And here it could be interesting to attract people, but this most likely also new players, I don't know. And this could be a path forward.
So I also know I guess the other factor is I do know that like the Zephyr has a safety community that meets, the Zen community has a safety community that meets, and they're all dealing with trying to figure out how these pieces all fit into systems. So I think having some place where people can sort of get together and talk about these things at least is going to be a useful service. Since I suspect more and more open source components are going to have to start dealing with this type of work going forward. Curious what some of the other folks on the call think about it. Gab? I'm going to pick on the other TSC members. Gab, Elena?
Gab, you're on mute still. You're on on the whatever kind of mute. It's most likely a Fedora mute still. Still on mute.
Still can't hear you. Okay.
Can you hear me now?
Yeah.
Yes.
Yeah. Now we can hear you. But maybe you cannot hear us anymore.
Hello?
Yeah, we can hear you.
on low volume,
yeah,
but
yeah, but now I cannot hear you.
Technology is so much fun.
Oh, no, now I can. Okay, good.
Yeah.
So yeah, sorry. Yes, I don't unmute. No, I was actually while you were speaking, I was looking up to see if there is any. I mean, in terms of safety application to consider, I would think any, I don't know, like torque monitoring or speed monitoring. These are typical, industrial safety applications that, may be interesting for the industrial working group. But I was also trying to see if I could find anything in the open, so something that we could reuse. But yeah, no, so far no luck. I was, I don't know. So because I mean, if I look at the automotive working group, right? So what we did there, so we started from the automotive grade Linux, and we used that as a sort of integration environment, right? And we developed a sort of ad hoc safety application, like the Telltale, that was designed from scratch. Effectively, wasn't there before we started. I'm just thinking if, from a technical point of view, we could do something similar with the ROS, maybe the robotic. I don't know. Just an
Yeah, no,
idea.
the Ross folk are interested in some of these areas, so maybe they're worth reaching out to
Mm,
and see if they've got something that they want to point us at and say, hey, yeah, they wouldn't mind working with us on.
right.
I think we can get some system level analysis. I think we probably want to at least have this group focusing on the system issues rather than just the industrial application, one industrial application,
Mhm.
how an application works in the system, because I think that is the gap as well.
seeing an automotive use case would be straightforward, but it's something which we already have to some extent, and then we just can say we take the automotive work group and put it into larger picture and put into a system. But the architecture is quite similar for a lot of these use cases, and I guess we know how hard it is to get automotive people in to share information. That's how you said we basically developed the Telltale from scratch because nobody shared the architecture with us, and we discussed a long time about NDA, so that's why we ended up with a QMO to just get rid of all these obstacles. And this is something which we definitely face with automotive. Otherwise, we would have the architecture use case, of course. Yeah.
So the other thing too is possibly doing something on a simulator environment as well as neutral hardware. So we have that whole QMU because a lot of development is being done there. It certainly is a factor anyhow, knowing that people are going to potentially have to be working on that sort of information and things. We can get a lot of information out of simulators too that can be useful for this.
Yeah.
Okay. So I think sort of we've picked on Gab. Who else is on from the TSC? Alana, what's your thoughts on this one? Oh, is she unmuting her hearing or not? No.
Still on mute.
Oh.
So it seems to me that while Ilana is coming in, seems to me that we have to identify industrial area, that use case, small or large. We have to decide which one we would want to tackle. And is there are we looking at control systems? Are we looking at what kind of industrial automation are we looking at? Are we looking at automation? And what kind of industrial? There are a couple of open source. What is fully open source? What is the software that we're looking at? That's kind of we're looking at it. We have several industrial type automations happening, correct? Like, for example, one thing that comes to my mind is the turbines, wind turbines. Linux-based systems are used to control the turning them off and on. Those are small devices. I don't know how much of an open source software runs on them.
I can tell you from that one, from the Zephyr perspective, it took us a long time to even get them to admit they were using Zephyr.
Okay.
Okay.
So they use their homegrown thing then.
Yeah. So they've got their own homegrown systems, and they're using Zephyrs to control some of the sensors and actuators.
Mm-hmm.
I think in those turbines, and that's a feeding data sources, but they're part of a system. So I don't think we can quite get some of that. I know there's I think there's some energy grid stuff, but that really doesn't fit into this space.
Yeah, you really need an application where you need an operating system like Linux to do some heavy lifting rather than just using an RTOS.
Right.
So it's finding an application where you need the sort of the safety angle as well as the performance
and the functionality.
The functionality, yeah. Coming at this from a different angle, there was a talk I had at FOSDEM a couple of years ago about an open source application framework for interprocess communication, which I think had been developed with automotive in mind, but it was fundamentally they were looking at safety certifying it. They were developing it primarily for use on, I think, on QNX, but they were actually developing it with Linux, but they didn't know a way to make the sort of the safety claims about Linux. Again, we could look at something like that, where we've got a partner who's interested, who have a concrete system that we could look at what its dependencies on the kernel were, and say, okay, how would you make a safety claim around this? It's a bit abstract, but if you maybe talking to them and saying, can you do you have a concrete use case for this that we could perhaps piggyback on?
Mm-hmm.
I'll put a link to the project on the chat. ISORIX.
Oh, yeah.
Yeah.
This turned into, actually, isn't it? That turned into another project afterwards.
Yeah, there was I think there was an OS based on it.
Or isn't it open ADX
Apex.
or something? Apex OS, right? I guess they made all of it. Yeah. It could be that they also are contributing these days to the, but here I'm not sure about if I get them right or not. It could be that they are also that's how do they call it? Where tier 4's AutoWare, that they put this, because this was ROS based, and then on Linux also they had this pass from AutoWare, and coming away from proprietary IP driven RTOS or OS. Yeah.
I'm almost wondering, I'm sort of wondering if we might want to reach out to the ROS folk and see if they can help point us at an application.
Yeah, that's another good idea.
Yeah.
And maybe go into some of their repos and so forth. Okay, so I guess to move this forward, probably and I think one of the action items to take out of this is reaching out to the ROS folk and see if they can, they've got some ideas as to what they want to see here. Do we want to start just looking, though, at systems using some of the stuff that we already have from medical or from automotive, just from a systems perspective in the interim before we identify the app, or not? The open app, an open industrial app. Because like I say, we've got the issues. I don't think the medical group is really going after, talking about how do you update all the issues on the Raspberry Pi and the distro, the Raspberry Pi distro where Linux is on. But we know that these are going to be factors in effective utilization of the device.
I get that,
Um,
Paul.
I mean, that's something I've spent a lot of time looking at. So, yeah, I could definitely provide a steer on that. But again, it would be useful to actually have a concrete system to think about.
Well, the home automation ones, there should be things out there for the home.
Yeah, I guess.
Okay.
This could be a good one to also, and I think partially they also take ROS into account. At least this vacuum cleaner thing, I guess they also have taken elements of ROS. Maybe, I'm not sure, but I could imagine that this gets in there. Because there's robotics, right, moving around. Yeah.
I was wondering if some IoT use cases might be interesting as well. So again, where an IoT device is part of a larger safety argument for whatever. I mean, cars are stuffed full of IoT things these days as well. So that could link with the automotive, but it might mean that we could kind of focus on a different use case and bring in some different expertise. Are there some other forums, open source forums, focused around, apart from ROS, focused around industrial IoT that we could contact and say, have you got some use cases that have a safety angle?
Yeah.
At least I mean it's a mixture between safety and security. For security, there you find easy example, but I get there's a lot of devices also industrial. I heard a podcast about where they put sensor data in. They started with one sensor, now progressing 600 sensor data, different kind of data on their devices to identify if there is any risk on that drill. So they measure vibrations and everything, bring it to the cloud as an IoT device, control it from there. And the next thing is that they are trying to do remote repair. If they can change parameter, do updates, parameter settings to keep the drill working for a certain amount of time until the spare part is in. And then of course there could be safety considerations coming in the picture again. So if there's how to use, what to use, if you enable the attack path that someone can control this device which another person is using, you need to make sure that nothing goes wrong, right, in the configurations you're doing. And so
yeah, I've come across similar things in the medical domain where you have big heavy duty medical equipment deployed in hospitals and you want to monitor it to determine when it needs maintenance. So you have a kind of an edge device connected to it that you're then kind of connecting with your sort of monitoring systems. So there's a safety dimension to that, although it's a kind of a lower level one because it's about detecting when it's going to break rather than that it has broken. But even so, there might be some room there.
And I guess this is very interesting because it shows there is a lot of potential in there and also safety related functionality in such a system application and system use case. And at least from my starting, when I started the discussion, I wanted to see if there is some room for such an activity in ELISA, and it sounds like there is a good way.
I think there's interest, definitely, or at least I'm not seeing anyone say no.
Yeah, this is just the point. Yeah.
Okay, so I think I'm going to go over to the next session, but if anyone else wants to sort of stay here and comment, they're welcome to for a bit. I think I see people starting to wrap up too. Yeah. So I guess next steps, we talk about this in the TSC meeting.
We can do that.
2 weeks time.
Yeah.
Yep.
I just noticed rapid SCADA. I don't know if that's an option for us. I can do some research and we can talk about that.
Okay, let's start.
So it runs on Raspberry Pi, by the way, Kate. So.
Oh boy, we're going to be really. We need to reach out to the Raspberry Pi folk. It sounds like as well.
Right.
They may have some good applications too for us, right?
Right, like greenhouse automation. So it sounds like something that they are doing. So, but we can talk about that in the TSC. Thank you, Philip, for
Thank you, Philip, for leading this.
Yeah. Bye. Thanks a lot.
Bye.